choppers. All you wanna do is ride, ride, Sally. Ride, Sally, ride. All you wanna do is ride, ride, Sally. Ride, Sally, ride.
Okay, hello there. Today I'm going to show you about Chapter 1-3 for Algebra 2, the Algebraic Expressions section. I'm just going to kind of jump right in. So algebraic expression is, something that's, doesn't usually have an equal sign. You're kind of just combining like terms. Sometimes you're writing an expression for the words, and that's how we're going to start here with the first one. Which algebraic expression models the word or phrase 7 fewer than a number t? So this one's a little tricky because, when I say 7 fewer than, the word fewer than implies subtraction, okay? If I However, if I said I had $7 fewer than you and you have $20, that's not 7 minus 20 because that would give me, negative 13. It's 20 minus 7. So 7 fewer than means you subtract 7 from it, which means, if I'm working with T, that would be 7 fewer than. So that would be C. Very often that's the one I would mess up. I would put D by accident. All right, so that's the first one. Second one, write an algebraic expression for 2 times the sum of A and B. So sum, that word means addition. So if I go A plus B, that would be my sum. Now I'm going to multiply it by 2. However, this doesn't quite cover it because this is really 2 times A plus B, which isn't really what the words are saying up there. They say write an expression for 2 times the sum of A and B. So they want you to add together first, which means you really got to throw parentheses around that so that's the sum of A and B, and then you're going to double that. So that would be the correct answer. Number 3, you start with $20 and save $6 each week. What algebraic expression models the total amount that you save? All right, so we're going to use W equals the number of weeks. It's always good to label your variables. So let's see. I started with $20 and then I go up $6 each week. So, if I had $6 after 1 week, then after 2 weeks I'd have $12. After 3 weeks I'd have $18. So I'm multiplying by the 6 times the number of weeks. So that's how I'm going to start this, 6 times W or just regular 6W. And then I had $20 to start, so I'm going to add 20. And, this would equal the total amount, I don't know, total T, something like that. You probably don't even need that equals total. I just put it there just because when it deals with money, when they talk about a total amount you save, that would be on the other side of the equal sign. All right, so number 4. This one, a little different. What is the value of the expression for the given values of the variables? So they give me this expression on the left side, 7 times A plus 4 plus 3B minus 8. But then they tell me over here that A is 4 and B is 5. So maybe I'll take this expression, I'll rewrite it, except for where the B is, you got to use parentheses there too. Anytime you're substituting a value in for a variable, you got to use parentheses. So technically this should have it too, which gives you parentheses and parentheses. Of course, yep, that's in the right spot. Okay, I'll put the 5 in for the B. All right, so now let me start simplifying this. Order of operations, parentheses first, right? Then exponents. So I have parentheses, I don't have exponents. So negative 4 plus 4 is 0. So I got 7 times 0 plus 3 times 5 is 15. I'm doing my multiplication at the same time there. You really should do multiplication, division left to right. So I probably should have waited on that, multiplying the 3 times the 5. In this case, it's not going to change anything. 7 times 0, that's 0. So 0 plus 15 minus 8. And we do addition and subtraction left to right. 0 plus 15 is 15. 15 minus 8 is 7. And that's the answer. Same directions, different problems. All right, so I'm going to take that 1 and plug it in for the x. And the y is going to be 1/2 to the second power here. All right, so I plugged in the values over here. The x is 1 and y is 1/2. Kids often get scared by fractions. Don't be. All right, there's a real nice shortcut to this, taking 1/2 to the second power. I'm going to leave this as it is. I'm just taking away the parentheses on the right. Now, the shortcut is when you have a fraction to a power like that, outside the parentheses, you can square the numerator and you can square the denominator. I mean, you can punch that in your calculator also and figure out that it's 1/4. Or I can go like this, which is 1/2 plus 1/4. Common denominators would be good here to add. Adding and subtracting fractions is hard. So if I took, the 1/4, I don't have to change, but the 1/2 I will. Let's see, if I multiplied the denominator by 2 to get to 4, then I should multiply the numerator by 2 also, which will give me 2/4. 2/4 plus 1/4 is 3/4. And that's the answer, or 0.75. We could have changed them to decimals too. That would have worked as well. All right, number 6. You got part A and B in this one. Football. In football, a touchdown is worth 6 points. A field goal is worth 3 points. And it doesn't say it, but extra points are worth 1 point. What algebraic expression models the total number of points in the game? All right, so I guess with this one, what they gave us so far is, 6 points. We'll have T be the number of touchdowns. We'll have extra points here? No, they don't. So they're doing field goals. So we'll go F for field goals. All right, so 6 points for a touchdown. So that would be 6 times T. Field goals are worth 3 points. So if I add those together, that would give me the total number of points in the game. Now here's the silly part, because part B, all of a sudden, now they throw in the extra points. I took this problem right out of the book, so I can blame Pearson's success net for that one. So now the extra points are worth 1 point. And let's say a football team scores 3 touchdowns, 2 extra points, and 4 field goals. How many points did they score? All right, so 3 equals T. F is going to be my field goals, which are worth, there were 4 field goals. And then I'm going to change this up here. So if I go 1E, and E will be extra points. All right, so if I plug these in, how many extra points did I have? I had 2. They scored 3 touchdowns and 2 extra points. Sounds like the Patriots. Okay, so if I plug these in, I go 6 times T plus 3 times F plus 1 times E. And I plug those numbers in here, I'll get my answer. So I got 3 touchdowns, 4 field goals, and 2 extra points. 3 times 6 is 18. 3 times 4 is 12. 1 times 2 is 2. 18 plus 12 is 30, and 30 plus 2 is 32 total points. And that would be the answer. All right, next. I got a few more properties to go through with you guys. These are actually, even though they're important to kind of put back out there, I know some of these things get covered in geometry, but it's important to keep some of these things straight. You will be seeing me use these throughout the semester or year. The first thing is about subtraction. I can say a minus b is the same as a plus negative b, all right? It's the same thing. I'll change them around. Sometimes I love taking that, subtraction sign and turning it into a plus negative, because it can be very helpful as far as not losing that negative. Also with division, I can write it a variety of ways. A divided by b is the same as a over b, like here. And I can also multiply a times 1 over b. That's all the same thing. I could take this a and then put it up into the top of the fraction and end up right back over here with a over b. So you can see that those are actually the same as well. And it can be very helpful to manipulate different types of expressions as one of those three things, depending on the situation. So once again, I got b in the denominator of fraction, so we're going to put this little clause over on the side here and say b cannot equal 0. That's what that equal with a slash through it means. Does not equal, cannot equal, one of those two. All right. Next, distributive property of subtraction. So, this is where I'm doing the distributive property, and there's a subtraction sign. There's nothing complicated about it. I multiply a times both the things in the parentheses. You get a times b minus a times c. And that's it. The opposite of a sum. This is important. A lot of kids make mistakes on this. A lot of adults make mistakes on this too. This is where I've got parentheses, two things combined inside the parentheses by addition, and then a negative sign outside the parentheses. So this is really along the same lines of the distributive property. I'm distributing that subtraction sign to both these things inside the parentheses. So both a and b become negative. That would be one way to do it. You could also say negative a minus b. Remember, that's the same as plus negative, which means it's the same thing as in the middle, just a different way to write it. Okay, so that would be the opposite of a sum. The opposite of a difference is the same idea. I'm distributing that negative sign, so whatever's in the parentheses, if it's negative, you make it positive. If it's positive, you make it negative. So that b is negative inside the parentheses because the subtraction sign sticks to the b, not to the a. So then it becomes plus b. The a becomes negative, so you get negative a plus b, or you could switch the order, put the positive b first and the negative a after, and get b minus a. So they're all the same thing. Okay, next. We're getting into simplifying. So, simplifying, I can only combine like terms. I can add x's with x's, y's with y's, x squareds with x squareds, y squareds with y squareds. Can't add x squareds and y squareds. Please don't. They have to be the same variable. They have to be the same exponent. So, in this one I can combine 7x squared and negative 4x squared. When I add those two together, I keep the x squared as it is. Don't change the exponents. And then I just take the coefficients and combine them. I got the 7 and the negative 4, and when I add those two things together, I get 3. So I got 3x squareds. Next, I can take the y squareds. 3y squared plus 2y squared is 5y squared. All right. Notice how I didn't add the exponents. That's when you multiply. Try to keep that part straight, please. Questions? If you have them, bring them to class. All right, 8. Simplify the expression here. All right, so I got this negative sign out here. I'm going to distribute that to both things in here. I'm going to make that 3k and the m negative in this case. So I got negative 3k. Now you can either go minus m or plus negative m. It doesn't matter. I'm going to just put minus m. I'm going to distribute the 2 on the right side of the parentheses here. So 2 times k is 2k. Keep the subtraction sign. 2 times 4m is 8m. So I got minus 8m plus 2k. Okay, so I can combine some of these. I can combine my k's, and I can also combine my m's, but don't add k's with m's. All right, so negative 3k plus 2k. Negative 3 plus 2 is negative 1k, or just negative k, same thing. I'll leave it there just so I don't have to do the work of erasing it. Negative m and negative 8m. So there's an implied 1 in front of that m anytime it's not written there. So negative 1 plus negative 8 is negative 9m, or minus 9m, one of those two. All right, so that's the answer. You try. So I'm going to have you try this one, and I'll go through it in a minute. So you should hit pause, do you try, see if you can get the same answer, and I'll show you how to do it in a minute. Okay, welcome back. So I'm going to I start right here with this parentheses, and I'm going to change both the signs inside the parentheses. Get that out of the way first. So that 3t becomes negative. This 5r becomes positive 5r. The 8r I just leave alone. Now I can combine like terms. I can add my r's together, but not the t's. 8r plus 5r is 13r minus 3t, and that's as good as it gets. Please don't add those together at all. 10. Good news, my last problem. So this one, I'm going to distribute this, and I'll get 3y minus xy plus x squared. Yeah, that's as far as I can get. Please don't add anything together. You know, xy's I can only combine with other xy's. Y's I have to go with y's, x's with x's. So sometimes there's a point in math where in order to get the right answer, you got to stop. Don't go any farther, you know, because sometimes I see some horrific things that kids do at this point and after. They just start adding everything together and they get, 2x squared, y squared, I don't even know, whatever. Just this is the answer. Stop there. You can no longer combine any of that together. All right? All right, so I think that's all I got for today. Yep. All right, great. If you have any questions, write them down, bring them to class. I'm going to close out with a little bit more music.
You want to survive without selling.